Stranded wire is specifically required for wiring a spray booth, and solid copper wire cannot be used. This requirement stems from the superior flexibility and durability of stranded wire compared to solid copper wire in environments prone to vibration and movement, such as a spray booth. Solid copper wire, being more brittle, is susceptible to breakage when subjected to repeated bending or vibration. The National Fire Protection Association, or NFPA, mandates the use of stranded wire for all wiring within spray booths to mitigate the risk of fire in the event of a short circuit. Stranded wire's construction makes it less prone to failure under stress, thereby reducing the likelihood of electrical hazards. When wiring a spray booth, it is crucial to select stranded wire of the appropriate size, determined by the amperage of the electrical circuit it will serve. Furthermore, utilizing approved connectors, such as wire nuts, is essential for establishing secure and reliable electrical connections. Adhering to these guidelines ensures a safe and code-compliant electrical installation in spray booth environments. The requirement to use stranded wire instead of solid wire in a spray booth is directly related to safety and operational reliability. Consider the mechanical stresses placed on wiring within a spray booth environment. The equipment used in spray booths, such as spray guns, ventilation systems, and lighting, often generates vibrations. Solid wire, while adequate for many stationary applications, is not designed to withstand continuous flexing or vibration. Over time, this can lead to work hardening of the copper, making it brittle and prone to cracking. A cracked or broken conductor can create a high resistance point in the circuit, leading to heat buildup, which in turn increases the risk of fire. Stranded wire, on the other hand, is constructed of multiple thin strands of copper bundled together. This construction provides significantly greater flexibility and fatigue resistance. The individual strands can move relative to each other, allowing the wire to bend and flex without concentrating stress in any one point. This inherent flexibility allows stranded wire to better absorb the vibrations and movements common in spray booth environments, significantly reducing the risk of conductor failure and subsequent electrical hazards. The NFPA, a leading authority on fire safety, recognizes this critical difference in material properties. The standards set forth by the NFPA for spray booth wiring are intended to minimize fire risks associated with the use of flammable materials and electrical equipment. Requiring stranded wire is a key element of these safety standards. Furthermore, consider the potential consequences of a short circuit within a spray booth. Spray booths often contain flammable liquids and vapors. A short circuit can generate intense heat and sparks, which could easily ignite these flammable substances, leading to a fire or explosion. Stranded wire, by virtue of its greater durability and resistance to breakage, reduces the likelihood of a short circuit occurring in the first place. Moreover, properly installed and sized stranded wire will typically offer lower impedance than solid wire due to the skin effect phenomenon at higher frequencies, although this is usually negligible at power frequencies and short wire lengths used in a spray booth. Wire size selection for spray booth wiring is also of paramount importance. The wire must be appropriately sized to handle the maximum current draw of the circuit it serves. Undersized wire can overheat, leading to insulation breakdown, short circuits, and fires. The National Electrical Code, or NEC, provides detailed tables and guidelines for determining the appropriate wire size based on the amperage of the circuit, the type of insulation, and the ambient temperature. For example, NEC Table 310.15b16 details the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air based on conductor size. This table specifies the maximum current a conductor can safely carry without exceeding its temperature rating. It is crucial to consult this table and other relevant NEC sections to ensure that the selected wire size is adequate for the intended application. In addition to wire size, the type of insulation is also an important consideration. Spray booths may be subject to exposure to various chemicals and solvents. The insulation used on the wire must be resistant to these substances to prevent degradation and potential electrical hazards. The NEC specifies different types of insulation with varying degrees of resistance to chemicals, heat, and moisture. Selecting the appropriate insulation type is essential for ensuring the long-term reliability and safety of the wiring system. Approved connectors, such as wire nuts or crimp connectors, are also critical for making secure and reliable electrical connections. These connectors are designed to provide a mechanically strong and electrically sound connection between wires. Improperly installed or substandard connectors can lead to loose connections, increased resistance, and potential overheating. The NEC specifies requirements for the types of connectors that can be used in different applications. It is important to use connectors that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all to ensure that they meet applicable safety standards. When making wire connections, it is also important to follow proper installation techniques. This includes stripping the insulation to the correct length, twisting the wires together tightly, and securely tightening the connector. Improperly made connections can lead to loose connections, increased resistance, and potential overheating. In summary, the requirement to use stranded wire in spray booth wiring is based on sound engineering principles and safety considerations. Stranded wire's superior flexibility and resistance to vibration make it the ideal choice for this application. By following the guidelines set forth by the NFPA and the NEC and using properly sized wire, appropriate insulation, and approved connectors, you can ensure safe and reliable electrical installation in a spray booth environment. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical wiring. Ignoring these recommendations could lead to serious safety consequences. The use of stranded wire in spray booths isn't merely a suggestion, it's a mandated safety protocol designed to protect lives and property. The inherent properties of stranded wire significantly reduce the risk of electrical failures, which can have devastating consequences in a potentially explosive environment. Let's delve deeper into why solid core wire is unsuitable for spray booth applications and the benefits of using stranded wire. Firstly, solid core wire, typically composed of a single, thick strand of copper, lacks the flexibility required to withstand the constant vibrations and movements within a spray booth. These vibrations can stem from various sources, including spray equipment, ventilation systems, and even the movement of personnel working within the booth. Over time, the rigid nature of solid core wire makes it susceptible to fatigue and cracking, particularly at connection points. These cracks can lead to increased electrical resistance, generating heat, and ultimately creating a fire hazard. Furthermore, the National Electrical Code, or NEC, and other regulatory bodies explicitly discourage or prohibit the use of solid core wire in applications where flexibility and vibration resistance are critical. These codes are developed based on extensive research and analysis of electrical failures and are designed to minimize the risk of electrical fires and other hazards. Stranded wire, conversely, offers superior flexibility and resilience due to its construction. It comprises multiple thin strands of copper twisted together, allowing the wire to bend and flex without concentrating stress on any single point. This inherent flexibility makes stranded wire far less prone to fatigue and cracking, ensuring a more reliable and safer electrical connection over time. Secondly, the use of stranded wire also facilitates easier and more secure connections. The individual strands conform better to the shape of the terminal or connector, creating a larger contact area and reducing the risk of loose connections. Loose connections can lead to increased resistance, heat generation, and potential arcing, all of which pose significant fire hazards. Thirdly, the ampacity, or current carrying capacity, of stranded wire is generally higher than that of solid core wire of the same gauge. This is because the increased surface area of the multiple strands allows for better heat dissipation. In a spray booth environment, where electrical equipment often operates at or near its maximum capacity, the higher ampacity of stranded wire can provide added margin of safety. When selecting stranded wire for a spray booth application, it's essential to choose the appropriate gauge and insulation type. The gauge of the wire should be determined based on the amperage of the circuit and the length of the run, following the guidelines outlined in the NEC. The insulation type should be suitable for the environmental conditions within the spray booth, including exposure to solvents, chemicals, and temperature variations. Commonly used insulation types for spray booth wiring include THHN, THWN, and XHHW. These insulation types offer excellent resistance to heat, moisture, and chemicals, ensuring long-term reliability and safety. In addition to selecting the right wire, it's also crucial to use appropriate connectors and wiring techniques. Wire nuts, crimp connectors, and terminal blocks are all acceptable methods for making electrical connections in a spray booth, provided they are properly installed and rated for the intended application. When using wire nuts, it's important to strip the wires to the correct length, twist them together tightly, and ensure that the wire nut is securely tightened. When using crimp connectors, it's essential to use the correct crimping tool and die to ensure a secure and reliable connection. Terminal blocks provide a convenient and organized way to terminate multiple wires in a spray booth. Regardless of the connection method used, it's crucial to follow all applicable electrical codes and safety standards. Finally, regular inspection and maintenance of the electrical system in a spray booth are essential for ensuring continued safety and reliability. This includes checking for loose connections, damaged wiring, and any signs of overheating. Any problems should be addressed promptly by a qualified electrician. By adhering to these best practices, you can minimize the risk of electrical failures and ensure a safe and productive working environment in your spray booth. Remember, electrical safety is paramount, and it's always best to err on the side of caution when dealing with electrical wiring. Consult with a qualified electrician if you have any questions or concerns. Stranded wire's advantages extend beyond mere flexibility. Its design contributes to enhanced conductivity, which is crucial in demanding electrical applications. The increased surface area resulting from multiple strands provides a larger pathway for electron flow compared to a solid conductor of the same gauge. This translates to lower impedance and reduced voltage drop, particularly over longer distances. This enhanced conductivity is particularly beneficial in spray booths where consistent power delivery is essential for optimal equipment performance. Moreover, stranded wire is less susceptible to the skin effect, a phenomenon where alternating current tends to flow along the surface of a conductor rather than through its core. This effect becomes more pronounced at higher frequencies. By distributing the current flow across multiple strands, stranded wire minimizes the skin effect, resulting in more efficient current transmission. In terms of safety, stranded wire's flexibility reduces the likelihood of insulation damage during installation and maintenance. Solid core wire, being less pliable, is more prone to kinking or bending sharply, which can compromise the integrity of the insulation. Damaged insulation can expose the conductor, creating a shock hazard and increasing the risk of short circuits. Stranded wire's ability to bend and conform to tight spaces minimizes the risk of insulation damage, promoting a safer and more reliable installation. Furthermore, the individual strands of stranded wire act as fuses in the event of a fault. If a short circuit or overload occurs, the individual strands will melt and break, interrupting the current flow and preventing a more serious electrical incident. This self-fusing characteristic provides an added layer of protection in spray booth environments where flammable materials are present. When specifying stranded wire for spray booth applications, it's important to consider the stranding configuration. The stranding configuration refers to the number and arrangement of individual strands within the wire. Common stranding configurations include 7-strand, 19-strand, and 37-strand. A higher strand count generally results in greater flexibility and fatigue resistance. For spray booth wiring, a minimum of 19-strand wire is typically recommended to provide adequate flexibility and durability. The selection of appropriate connectors for stranded wire is also critical for ensuring a reliable and safe electrical connection. Compression connectors, which crimp onto the wire, are generally preferred over screw-type connectors, as they provide a more secure and vibration-resistant connection. When using compression connectors, it's important to use the correct crimping tool and die to ensure a proper crimp. The crimp should be tight and secure, without damaging the wire or the connector. In addition to compression connectors, terminal blocks are also commonly used in spray booth wiring. Terminal blocks provide a convenient and organized way to terminate multiple wires. When using terminal blocks, it's important to ensure that the wires are securely fastened and that the terminals are properly rated for the intended application. Proper grounding is another essential aspect of electrical safety in spray booths. Grounding provides a low-resistance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The grounding system in a spray booth should be designed and installed in accordance with the NEC and other applicable codes. All metal parts of the spray booth, including the enclosure, ventilation system, and equipment, should be properly grounded. The grounding conductor should be sized appropriately for the circuit and should be securely connected to a grounding electrode, such as a ground rod or metal water pipe. Regular testing of the grounding system is also essential to ensure its effectiveness. A ground resistance tester can be used to measure the resistance of the grounding system. If the resistance is too high, the grounding system should be inspected and repaired. In summary, the use of stranded wire in spray booths is a critical safety measure that should not be overlooked. Stranded wire's superior flexibility, conductivity, and safety characteristics make it the ideal choice for this demanding application. By following the guidelines outlined in the NEC and other applicable codes, and using properly sized wire, appropriate connectors, and a properly grounded system, you can ensure a safe and reliable electrical installation in your spray booth.